Hello and welcome to the lab. Today on the bench will be something, but I would also like to welcome you to the 2,000 subscriber video. I did not expect this when I started the channel 3 years ago, and we've hit 2,000 subscribers. So thank you to everybody who has joined and continues to join in videos. You guys are the reason the channel exists and videos continue to go out. The community around this channel has been absolutely phenomenal and amazing, and I love being a part of it. There's no words. I can't say thank you enough for being here and helping this channel get where it is today. As tradition, when I started the channel, as we tick over on the most significant digit of the subscriber count, I tend to go a little crazy and break the budget for the lab and add some capabilities. This is equipment that I would use anyway, but noting the milestone is a good way for me to say, do it now and get it going. I already have 3,000 and 4,000 planned. We'll have to get there to find out. So thank you again to everybody who hit the subscribe button, the bell, and the like or dislike on the videos, and also have given me feedback over the years in the comments section. It has been invaluable to get the lab where it is today. So with that being said, let me grab the box. So we have a smallish box this time from Keysight. So for those that are curious, the lab does not have any sponsors. This video is not sponsored by Keysight in any way. They got my money, same as if you went out and purchased what is in the box, they would get your money. So I know when I show a piece of test equipment, some people go look it up and see it, but I've paid for it. Actually, I've paid for all of the equipment on the bench at the current going rate. There has never been a sponsor for the lab. That's not to say I won't take sponsors in the future, but I am incredibly choosy as to the sponsors that I would work with due to valuing the audience. So I don't want to, I want to stay independent. It lets me stay impartial and things like that. So with that, let's cut open the box. However, one thing to note, I am very surprised they shipped this without a signature required, given what this is. I ordered this through a company called Valuetronics. I have ordered stuff through those guys before. Always call them and ask for a quote. Typically, you will do better than list. However, they don't know me from anybody, and I've only bought a couple of pieces of equipment from them, so they aren't treating me any special. But if you do need test equipment, used or new, check them out and see if they can help out. We have a box of accessories. We'll open that here in a minute. Certificate of calibration, which means fun stuff in the box. Hopefully this one's in black. Should be, given that this is new. There's a beige unit of this. It is. And here we go. Really heavy box. I like that, given how delicate the equipment is. Let's take a look at the accessory box. What do we get? Power cord, I bet. Power cord, grounded, NEC North American plug, which I would expect for my area. USB 2 cable. And manual? Maybe? Nope. Box content list. Here we go. For those that saw the community post, probably already had a clue when the box said Keysight as to what it was, because I kind of teased the two options. What didn't get ordered for 2,000 will get ordered for 3,000. So we're good to go there. Let's talk about how I ordered this and why I ordered it this way, because this is a weird way to order one of these, but it also let me be a little frugal. So we are adding a 35230A to the lab, a 350 megahertz, 20 picosecond universal counter. This will be used for mostly frequency work and things like that. There's a couple of things that I haven't ordered with this unit that we will get into and go from there. The first thing you'll notice is I did not order a channel 3 with this unit. This unit puts an end connector right here, and it gets a microwave channel that can go from 100 kilohertz to 6 gigahertz or 300 kilohertz to 15 gigahertz for the channel 3. The reason I haven't ordered a channel 3 option yet is because my 53131A has a 3 gigahertz channel already, and I don't know if I want the 6 or 15 yet. So the nice thing about that is I checked with Keysight, and I also checked with Valuetronics. They confirmed it for me. This is field upgradable. I can order this directly from Keysight. They'll ship it here. Doesn't even need to be any calibrated. It's user installable. So we can take care of that in the future if we need to. The other thing that I did not order with this unit is, if we look at the options, it does not have a high stability time base in it. So the reason I did that is because this has an OCXO in it, and I'm already really pushing power burn in the lab anyway, so I didn't want to have a crystal staying hot all the time. And I also confirmed with the Keysight engineers that I wouldn't need it. The reason I can do the measurements that I want to do with this unit without the OCXO is because I have the rubidium standard in the lab, which we will be putting this on absolutely. Being that it's the version, it's the 230. Yes, 230 unit as opposed to the 220 or 210. We have most of the back fully populated. These are just mirrored inputs from the front. I don't plan on taking this out of the lab, so I did not order the battery option with this. It's just a lithium-ion battery, and I would use that so infrequently that the battery will just burn out and not I wouldn't get any benefit from it. But that's just my use case. That's nothing against the unit. We are going to hook this up to LAN, maybe USB. I'm going to try to do as much as I can on LAN. And we're going to do a lot of data collection with this. This comes with a license of BenchView from Keysight. We are going to get that installed on the lab computer. There's going to be lots of data logging that this is going to have to do in the lab for us. And one of the reasons why we picked up this unit, or I picked up this unit, is I've been asked to do some deeper evaluations of 10 megahertz references. So I will be picking up some 10 megahertz references from some auction sites, and we'll be crashing them against this and the rubidium standard. That's also another reason why I went with the 3 unit as opposed to the 2 or the 1 unit, the 30 versus the 20 and the 10. The main difference, which I'm going to use quite often, to be honest, is this does gapless capture. So this can run in a mode where there is no gate time. That's going to be important for seeing the wandering of the oscillators and things like that when we're looking at the GPSDOs. The other thing that's important is this 20 picosecond window. This is the fastest one they make, and actually that's an industry leading spec, and it's the fastest frequency counter that I know of. The other thing, the other reason that I went with the 230 unit is because it does Allen variants of oscillators directly in the unit. You don't need software, you don't need anything like this. This can do the Allen variants internally. The 20 and the 10 can both do it, but you need external software, do the data logging, do the Allen variants in Excel, things like that. This can show us the histograms and things right on the unit. And right in the module. So it'll make some of these measurements easier. What's going to happen to the 53131A that's been a staple of the channel for quite some time? That's going to roll down to here. So we're going to take this frequency counter, push it to here. This one's going to roll off the bench and go into storage. But if anybody is interested in a frequency counter, let me know, and we'll see what happens. So I'm going to fire up the rubidium to let that lock and get started. Then we're going to power this thing up. I have not even read the manual for this frequency counter yet. Kind of going in blind, and we're going to have some fun. We'll see how intuitive it is to get started with this without even looking at the manual first. But that's where the fun is. So let me get the rubidium warmed up and get a cable run to the external reference, and we'll go from there. While the rubidium warms up, I should also mention, along with channel 3 being a field installable unit, the OCXO, if I ever decide I would like that feature, I can send it into Keysight, and they are more than happy to put it in for me. No surprise there. Not a lot of people have the ability to calibrate an OCXO of that precision in-house, so they'll sell me the crystal, I'm sure, but they want to calibrate it before they send it back to me. So that's kind of the difference there. This is user installable. This needs to go through a cal lab. No shock there. The heart of the unit is the heart of a frequency counter is the time base, and if that's off, everything's off. So really no surprise with that response. I was very happy to learn, though, that both are upgradable later. So if I do need them, as long as this is the current model of frequency counter, we're good to go. Okay, I'm going to have a 10 megahertz signal coming off of the DG4162, which is on the rubidium, which is locked. I have 5 megahertz off of the rubidium here, which I'm going to use as the external base clock for this. One thing I also know from doing a little bit of research, or a lot of research on this particular unit, is the external clock can be 1, 5, or 10 megahertz. It's set internally. So I can use one of the 5 megahertz ports off the rubidium and free up the 10s for units that can't use 10. So what we're going to do is we're going to put some power to this, and we'll turn it on. Wow, the fan. Okay, that's good. The fan quieted down. It was really loud. I heard it over the air cleaner, which is kind of crazy. I do believe this is a touchy-feely screen. Let's see. Yes, tilting bail, pull out. Need help press and hold any key. No IP address yet, and GPIB. So we have AC coupled input, 1 megohm input impedance, and it's triggering at 50%, which is perfectly fine. I have a 2 volt peak-to-peak waveform here. See what we do if we kick on an output. And look at all the digits. Oh wow, let me get the glare off. Even turning the lights in the lab down, because the screen's backlit, it's confusing the camera. I'll zoom in here real quick. And there's the screen plain as day. So we're definitely going to tune the brightness down. This is a really bright screen. Okay. Utility, there's the button. Holy cow. System set up. It is not touchy-feely. Okay, that's kind of nice. I'm not a fan of touchscreens. I don't like fingers on the touchscreens. So it's soft buttons at the bottom. I know it's hard to see, but we're going to go to user settings, display options, brightness. Ah, there we go. Use the knob. That is at 1% brightness. Let me back out. It still blows out a little bit. So it was at 75. But if I go down to 5% display brightness, okay, we're going to leave it there. It's plenty bright. Screensaver is on. And display is on. That's fine for now. Time-based settings is, this is how, so time-based is set to auto, and the external reference is set to 10 megahertz. So what's interesting is we're seeing the local oscillator. This jumping around, this is the local clock in the machine, or in the 53230. We'll call it that. One of the things that I really like about this frequency counter is it tells you your signal input. So if you hook up a frequency counter, or if you hook up a signal, it gives you some rudimentary waveforms or waveform information, so you know if you're not blowing out the front end, which I really like. Let's go ahead and I will hook up. We'll set this to 5 megahertz. Let's hook up the 5 megahertz right here, and we'll see what happens. We'll set this to internal. Okay, we have our 5 megahertz hooked up. So let's set this to external. Much better. So we don't need the super high stability time base because of the rubidium that's already in the lab. So it's allowing me to leverage some of the earlier purchases to save a little bit on this one. The other thing is, without the OCXO, when I turn this off, it will be then off, not, because with the OCXO installed on this, there's 2 modes of off. There's standby, which is keeping the heater running in the OCXO, and then there's true off, which allows the OCXO to get cold. The main difference between the two is warm-up time. So one way, it warms up much quicker than the other way, because it can take quite a while for a oven-controlled oscillator to stabilize. Using my Type 184 as a reference, if the oven's truly cold, 4.5 hours plus 30 minutes of on time to get the thing to stabilize. So depending on how precise you need it to be, that's a consideration. So now let's take a look at how precise this frequency counter can actually get. So we have a decent 12 digits of resolution right there, which is what my 53131A can do. But if I turn auto digits off, I can go out to 15 digits of resolution with this. This is one of the reasons why we picked up this unit for analyzing the GPS DOs, because I'm interested in what's happening out here. This is all fine. I expect a GPS DO to be stable in here. I want to know what's going on down here. Now we can smooth this out. Let's increase the gate time. Obviously, we've slowed the counter way down, but we're getting a lot more accuracy in counts at this point. And this is only at 1 second. When I was setting up the previous frequency counter, I was setting it at 10 seconds gate time. So this is going to collect data a lot quicker. So we're going to get to really see how stuff's wandering around, which is testing that I've been looking forward to doing. So lots of digits on this one. One of the other neat ones for this one is we have graphs, and we will, let's see if I can reset this. Clear readings? Yes. So now it'll tell us how the function generator is wandering. So for a function generator, this is a pretty stable clock, but I also have my function generators biased to the rubidium as well. And this is really what the rubidium does for the lab. It just tightens up all these clocks to a level that would be unattainable or difficult to attain in another way. But some of the testing we're looking forward to doing is how good does a GPSDO get you to rubidium. Now, I could take the lab reference one step higher, go to cesium, but we are really splitting hairs at that point. If I remember the spec sheets right, rubidium is at 10 to the minus 13, cesium's at 10 to the minus 14. So we're at that point where there is now huge investment to get just the last tiniest fraction of accuracy out of the clocks. So plenty good for what I'm doing, but pretty far down the rabbit hole. One of the other ways to look at oscillators, and this is the one of the ways I want to look at the GPSDOs, is I can do a histogram chart where we can it should end up with a bell curve distribution as the GPSDO wanders around, but it'll give us an idea on how much it's wandering, things like that. So really interested in collecting a bunch of data in this mode too. So you have histogram, and then you have, oh yeah, you can go to trend chart, and you can plot the trends as well as the histogram. So the other thing is you have min-max and span readings up at the top. This will do standard deviations and everything as well. So will really let us dig into some precision. Now, I do know this, a lot of people got mad at me for the Keithley, and so we will take the tape off. Since this is not a touchy-feely screen, I don't need to worry about it too much. With the Keithley being a touchscreen, God, that made the glare worse. With the Keithley being a touchscreen, I want to get a screen protector on it because my fingers are going to be on it. So as soon as I find a screen protector for it, a true screen protector, I'll peel the shipping film off. But also, I should note, this display is very nice to read in the lab. Even at this low brightness, this is still, if I go back to utility, display brightness is still at 5%, easily readable across the lab, no problem whatsoever. So, also the up and down aspect is very nice on this LCD screen as well, so no readability problems. So what I'm going to do now is I'm going to move some stuff around in the lab. We're going to throw this up in its home. Oh, kind of makes it easier to film. So we're going to throw this up in its home up top. I'm going to move the 53131A down to on the scope. Run this data cable to it, and it's going to be home for a while. So since I have to climb around the bench, get behind things and everything like that, I will put the camera on pause. So through the magic of video, I will be right back, but I got a bit of work to do. Also, before I head out, or before I move everything around, we're getting this level of accuracy off of a function generator. Not a signal source, not a precision oscillator, but a function generator. Good on Rigol. One thing also to note, as I'm putting everything up in the lab, here's the old frequency counter, here's a new one. The new one's a little shorter than the old one, so this is causing me a little bit of problems in the equipment stack up because I had frequency counter, meter, power meter. This is going to have to go above the meter, so it's going to be DMM, frequency counter, power meter. Not really a problem, but the depth is causing me a bit of an issue. Okay, one thing of interest to note, I have both frequency counters set up the same way, so we have a 1 second gate time on each. However, the external reference for this one is what the old frequency counter was using, the square wave coming off the GPSDO. The reference for this one is the 5 megahertz rubidium. They're the same line, so same signal going into both, although this is coming through the scope, the 7603, but we're off a little bit. So restarting the counter, got it counting again. We're still off a little bit. Well, we're down there 99941, so this is better. So I guess the counter was locked up a little bit. So when instrumentation lies, bump up the frequency. Very touchy control because I'm using the 200 CD for this. I gave it 2.5 volts of signal, so there's plenty to read. One 10178. So yeah, right here. Looks like these two digits are where they're disagreeing with each other. So not too bad, pretty close. We could tighten this up by throwing this on the rubidium, but we'll leave it on the GPSDO for now, because especially being a frequency counter for a scope, or that's hooked to the scope input, this is plenty good for a scope front end. With that, everything's found a new home. The 53131A moved down. The 53230 is up here. I have an instruction manual I have to read. As always, between videos, I will see everyone in the comments section. Comments do lead to videos. The soldering video that was recent being a example. So feel free to leave a comment, suggestion, or concern. All the comments are read. Click the subscribe button, share, and like to help the YouTube algorithm get these videos out there. And as always, I will see everyone in the next video. That's it for today.